Hi guys, so here we're looking at more example of multiplication or expanding. Let's start with this repeated root. So this is the same as equal to, so we have 4x minus 5 into, oh sorry, made a mistake. So this is the same as 4x minus 5, so we're saying it's a repeated root. So here we should have 4x times 4x, that will give us 16x squared. 4x times minus 5, this should give us minus 20x. Minus 5 times 4x, this should give us minus 20x. Minus 5 times minus 5 should give us positive 25. Okay, so we're looking at the like terms. So 16x squared remain the same. There's nothing that has a squared here. But if you're looking at the second term, we have minus 20x and minus 20x. So that should give us minus 40x, because the bases are the same. We just add the coefficient here. Okay, let's look at the plus 25. So this is our final answer. This is what we get. Let's look at second example. We can call this an example 1, right? Let's look at example 2. Well, when we're looking at our example 2, we have x minus 1 into x squared minus 2x plus 1. So this is multiplying a binomial by a trinomial. We do the same thing. We have to multiply x with x squared, we multiply it with the second term, and we multiply it with the last term as well. We do the same thing with this minus 1 here. We multiply it with that, and we multiply it with the middle term, and we multiply it with the last term. So let's get to it. So we have x times x squared, that gives us x cubed. We also have x times minus 2x, that gives us minus 2x squared, and we have x times 1, which is giving us x, and we're looking at minus 1 times x squared, that should give us x minus x squared, minus times minus 2x, this will give us plus 2x, and then minus times positive 1, minus 1 times positive 1, this will give us minus 1. Okay, and then we do the same thing. We look at the like term, so there's nothing else that is cubed beside x cubed. Let's look at the, so we have minus 2x squared here with minus x, so this should give us minus 3x squared. We're getting minus 3 because there is a 1 here. There's a 1 here, so we're just adding. So it's minus 2 minus 1 is minus 3. We keep the base the same because our base here is x squared. Alright, so let's look at x. We still have our x here, and we still have 2x here. That gives us 3x, and then we have minus 1. There's nothing that is also common here, so we're done with the second example. Alright, so let's look at our next example here. In this case, let's look like a little bit complicated, so let's quickly look at it then. So in this case we have, so this is example 3. Let's look at our example 3 as 5d squared into 4d cube plus 3 into, and a plus 3d cube into 6d squared plus 4. Okay, let's move this one to the other side, right? Okay, cool. So let's do this one. Well, we start from here. So we do the same thing. This is monomial multiplied by binomial. So we'll have 5 times 4, it gives us 20. D squared times d cube, it gives us d to the power 5. Remember, when the bases are the same, we just add the exponent. Always remember that. So the basis here is d and d, so we just add the exponent of which is 2 and 3. So we keep d the same and we're getting 5, right? And then we do the same thing, we multiplying 3. So the 5 times 3, it should give us plus 15 d squared. Then we have plus 3 times 6 should give us 18, should give us 18 d to the power 5, because it's 3 plus 2, that gives us 5. All right, and then we have 3 times 4, that is plus 3 times 4, that is plus 12 d cube. So you see, we do have like terms here, because we do have d to the power 5 and d to the power 5, so we need to add that. So that's sum to 36 d to the power 5 plus 15 d to the power 2 plus 12 d to the power 3. You can rearrange it to order, maybe to say 36 d to the power 5 plus 12 d to the power 3 plus 15 d to the power 2. So this is our solution. So we're done with the expansion, or we're done with the multiplication.